In this video, I'm going to help you prepare for your geometry final exam. So this is the second semester of geometry. If you're interested in the earlier topics, check out my video that I did for the geometry midterm. I'm going to have timestamps in the description below, so go down there if you want to hop to a particular type of problem that you maybe don't remember from your geometry class. But let's get into this video and I'll show you how to work through some of these different problems that you'll likely see on your exam. So question number one says solve for x. Okay, so this is kind of an easy problem. It's a right triangle, and we know that when you have a right triangle you can use what? Pythagorean theorem, right? So again, a quick refresher, a squared plus b squared equals c squared. A and B are the two sides that make up the right angle. Those are called the legs. The one across from the right angle, that's the longest side, that's the hypotenuse. So in this case, what we have is 3 squared plus 9 squared is equal to x squared. So if we simplify that, we get 9 plus 81 equals x squared, or you could say x squared equals 90, and then what you want to do is you want to take the square root of both sides. But remember, when you simplify radicals, you can split this up into square root of 9 times square root of 10. Square root of 9 is a perfect square, that's 3. So an exact answer here is going to be 3 square root of 10. Okay, so let's go to question number 2. Now, just a quick note, if any of these concepts are challenging, you kind of forgot about them, you can go over to my Mario's Math Tutoring YouTube channel page, and over there what I have is you just type in, what type of concept you're looking for, and it'll take you to those videos that I've done on these exact same topics. So this one says, which is not a Pythagorean triple? Okay, now this is a good question. Now, what exactly is a Pythagorean triple? Well, Pythagorean triple means that all three sides of the triangle are integers. So that means they're nice round numbers. There's not any decimals, fractions. They're nice round integers values, and they satisfy this equation here, a squared plus b squared equals c squared, the Pythagorean theorem. Now, the ones that come up most commonly, and these are the ones that you're going to want to memorize, are the 3, 4, 5, the 5, 12, 13, 8, 15, 17, and 7, 24, 25. Okay, now these are the ones that come up the most commonly. It's because these are the ones that have the smallest integer values, but you can multiply these by a constant. So for example, if I multiply this by 2, I get 6, 8, 10, and look right there, that's the first one. So I can see that this is a Pythagorean triple, meaning if I take 6 squared plus 8 squared, it does indeed equal 10 squared, so this does form a right triangle. But we're looking for the one that's not a Pythagorean triple. Now look at 14, 48, and 50. Well, you can see that's taking this one, multiplying everything by 2, so that's not one. How about this one, 3, 4, 6? Well, I don't see that one here. I've got 3, 4, 5. Let's test it out. So we've got 3 squared plus 4 squared question mark. 6 squared, does it equal 6 squared? Well, let's see, that's 9 plus 16, which is 25. Does that equal 36? No, it doesn't. So that means this is not a right triangle. That's the correct answer. But let's just check this last one really quick. 80, 150, 170, you can see they're taking this Pythagorean triple and they're multiplying everything by 10, so that forms a right triangle. Okay, so definitely an important concept, Pythagorean triples. Now number 3, is the triangle right, acute, obtuse, or not a triangle given the sides 5, 6, and 9? Well, the first thing we want to understand is that, the triangle inequality theorem. Okay, so what is the triangle inequality theorem? Well, the triangle inequality theorem says that if you add any two sides of a triangle together, they have to add up to more than the third side. If they don't, you'll have a drawbridge situation like this, where, say for example, this side is like 10, and this is 3, and this is like 5. You see, even if you were to fold these down, they're not going to be able to span that distance of 10. So any two sides have to add up to more than the third side, right? So let's check that first. So 5 plus 6 is 11, that's more than 9. 5 plus 9 is 14, that's more than 6. 9 plus 6 is 15, that's more than 5. So we know that this does form a right triangle. Now the next thing we want to look at is c squared greater than a squared plus b squared? Is it equal to, or is it less than? Now, which side is c, 5, 6, or 9? Well, the longest side, that's our c side, so that's going to be 9. So what we're testing here now is 9 squared blank 5 squared plus 6 squared. So it's like I took the Pythagorean theorem and I flipped it. I put the longest side here on the left, okay? So if we simplify that, we get 81. This is 25 and 36, which is 61, right? 81 is greater than 61. So what does that tell you? It tells you that this is obtuse, okay? If it's less than, then it's acute. If it's equal, it's right. Now, one way that I like to kind of remember it is, take a look at a right triangle like this. So if this is your C side, this is your A side, and this is your B side, this forms a right triangle. But what happens if you were to open this side C longer and longer? What is it going to do to this angle across here? it's going to be opening, opening, opening. This is going to become larger than 90 degrees. It's going to be obtuse. Whereas if c squared was less than a squared plus b squared, this is going to be closing down like this. It's going to make it less than 90. It's going to be acute. Okay, and of course, if it's equal, then it's going to be right. So this is a good question because it tests us on, whether it's right, acute, or obtuse. It also tests us on whether it forms a right triangle or even a triangle at all, okay, using the triangle inequality theorem. So let's go to question number 4. Which side lengths don't form a triangle? Okay, so we're back to our triangle inequality theorem again. So we're basically, if it's going to fail, I'll give you a little quick hint. If it's going to fail, if it's not going to form a right triangle, it's the two shorter sides that are not going to add up to more than the longest side. So we can save some time by just saying, oh, 3 and 4, those are the shorter sides. 3 plus 4 is 7. That's more than 6. So this is going to form a right triangle. And we're looking for which ones don't. Okay, so this one does. 2 plus 3 is 5, but that's not greater than 5. It has to add up to more than 5. So this one actually does not form a right, not a right triangle, but a triangle at all. Again, if I was to draw a picture, here's 5, here's 2, here's 3. See how it folds flat? 2 plus 3 just barely spans that distance of 5. And then over here, 15 plus 20 is 35. That is more than 30. So this one does form a triangle. So the best answer here is letter B. Okay, now number 5, what we're talking about in this question are the special right triangles, the 30, 60, 90, the 45, 45, 90. These are really important triangles to know. And I'll just show you real quick here. This is what you want to memorize. Okay, so you've got, when these two sides are 45, 90, these two angles are the same. This is a right angle. This is an isosceles triangle, meaning that these two sides are going to be the same. So let's just call these x and x. And then the one across from the right angle, that's the hypotenuse. That's going to be x times the square root of 2. So a quick refresher, if you know this side, you automatically know this side. If you know this side, you automatically know this side because they're the same. It's isosceles. But if you want to get to that hypotenuse, you want to multiply by the square root of 2. Now you might be saying, Mario, well, what do I do if they give me the hypotenuse? Well, then you divide by the square root of 2 to get back to the leg. Okay, so that's pretty straightforward. So let's do some of those first. So you can see here, if this is 8, then here x must also equal 8. And y must equal 8 square root of 2. That was easy. Let's do a little bit more challenging one. So now letter B, they're giving us the hypotenuse. So to go from the hypotenuse back to the leg, we're going to divide by the square root of 2. What's 10 divided by the square root of 2? Well, we don't want the square root of 2 in the denominator, so what I have to do is rationalize, okay, by multiplying by root 2 over root 2. That's like multiplying by 1, right? And square root of 2 times square root of 2 is square root of 4, which is 2. And then you can see the 10 and the 2 reduce, and we just get 5 square root of 2. So that's going to be y. That's also going to be x because they're the same. Now notice some of the notations that I'm writing here. So you notice how I didn't even write the angles. I just put these marks. Well, if these two angles are the same and this is a right angle, these are automatically 45 degrees, right? So just a quick refresher there. Now for C, D, and E, we're looking at the 30, 60, 90 special right triangle. And this is what you want to memorize here if you don't remember this from earlier in your class. It's x square root of 3, and 2x. Okay, so the idea is that the side across from the smallest angle, the 30-degree angle, that's your short leg. That's going to be x. The one across from the medium angle, the 60-degree angle, that's your longer leg. That's x times the square root of 3. And the one across from the right angle, that's the longest side. That's the hypotenuse. That's 2x. So just a quick refresher, if you have the shorter leg, it's pretty easy. You just have to double it to get the hypotenuse, or multiply by square root of 3 to get the longer leg. If they give you the hypotenuse, that's pretty easy. You just divide by 2 to get back to 1x, that's the shorter leg, and then multiply by square root of 3 to get to the longer leg. The tougher one is if they give you the longer leg, you have to divide by the square root of 3 and then double to get to the hypotenuse. So let's take a look at these examples. So if this side is 4, what's this side over here? Where we have to multiply by square root of 3, so this is going to be 4 root 3. And then here we have to double it, so this is going to be y equals 8. Okay, let's go over here to letter D. So here they're giving us the hypotenuse, that's the 2x side. So to go back to the 1x side, we have to divide by 2, so that means that x is equal to 6. And then to get to this longer leg, we multiply by the square root of 3, so that's 6 square root of 3. Last one here, letter E, what do we do to get from the longer leg to the shorter leg? Well, remember, we divide by the square root of 3. So this is going to be, let's see, divide by square root of 3. Now remember, you don't want that square root in the denominator, so what I'm doing here is I'm rationalizing by multiplying the top and bottom by square root of 3, which this will give you square root of 9, and square root of 9 is 3, and then 9 and 3 reduce, so this just comes out to 3 square root of 3, and then if we double it, that's going to give you 6 square roots of 3. So again, review the special right triangles if you need to, and let's go on to the next question. Okay, so if you're enjoying this video, share it with some of your classmates, some of your friends, so that they can get a better score on their geometry final too. But let's go to number 6 here. So here we're getting into some trigonometry, and all trigonometry means is it's trig, which is triangle, and metry, you know the measurements in triangles, whether it's the sides or the angles. And so here what we have is we have a right triangle, okay, with sides 8, 15, and 17. We want to find the sine of x, the cosine of x, tangent of x. Then we want to find the sine of y, cosine of y, and tangent of y. Now the key thing to remember here, if you've forgotten, is that SOHCAHTOA acronym, right? So the SOHCAHTOA acronym means if it's the sine, you take the opposite over the hypotenuse, cosine the adjacent over the hypotenuse, and the tangent the opposite side over the adjacent side. The nice thing about this acronym is it's always the second letter divided by the third letter, okay? So it's easy to remember. So let's take a look at sine of x. So sine of x means that you position yourself, or you stand at this vertex, this angle x, and you say, well, the sine is what? Opposite over hypotenuse. So opposite means across over hypotenuse, which is the one across from the right angle. So that's going to be 8 over 17, and you got it. How about the cosine of x? Cosine of x is adjacent over hypotenuse. So that's adjacent, that means next to, okay, but not the hypotenuse. So next to, that's this one, over the hypotenuse, which is across from the right angle. So that's 15 seventeenths, right? And then the tangent of x, tangent is opposite over adjacent. So opposite is across, adjacent is next to, so that's 8 fifteenths, right? 8 divided by 15. Okay, now we're going to switch positions. We're going to put our little guy over here at angle y. Okay, so you pretend like you're at this vertex, this angle, and sine is what? It's opposite, okay, over hypotenuse. So that's 15 over 17. Cosine is what? Adjacent, okay, next to over hypotenuse. So that's 8 over 17. And then the tangent is opposite over adjacent. So that's 15 over 8, and you got it. So just remember your SOHCAHTOA acronym. Okay, now number 7, it says find x and y. Okay, and they give us this triangle. So again, what I like to do is I like to think about, you know, my perspective. I like to position myself at the angle. So I'm over here at the 42-degree angle, and I like to figure out, okay, what trig function, sine, cosine, or tangent ties together the opposite side and the hypotenuse. We can see opposite and hypotenuse, that's sine. So what I do is I say sine of 42 degrees is equal to the opposite over the hypotenuse. Then all we have to do to get x by itself is do the opposite of dividing by 8, multiply both sides by 8, and it's going to be 8 times the sine of 42. Now let's get our calculators out. 8 sine of 42, it's about 5.4 if you round to the tenths. Okay, so that's going to be about 5.4. And if you want to solve for y, you can do adjacent and hypotenuse. So we're going to do cosine of 42 equals adjacent over hypotenuse. And again, instead of dividing by 8, we'll multiply both sides by 8. We get 8 cosine of 42. And let's see what that is approximately. Okay, that's about 5.9. Okay, so that's the idea with this one. Now, a lot of times students will say, well, once I find this side, can't I just do the Pythagorean theorem? And you can. The only downside to that is that if you make a mistake here, you're going to then make a mistake on the next one. The other thing is that if you round here, you could get a little bit of a rounding error if you keep rounding. So sometimes it's better to just go back to the original numbers if you can and work with those, because those are exact values. You're going to get a little bit more accurate answer. Okay, now question number 8, it says the angle of depression is 20 degrees. Which expression can you use to solve for h? So they give us this figure here. Okay, now a quick review of angle of elevation, angle of depression. Remember, elevation is like this. Like elevation, you're like elevating, you're looking up. Okay, so you're looking up, that's your line of sight from the horizontal. Depression is what? It's like you're looking down from the horizontal. Okay, so what I like to do with these problems is I like to go like this, making them into a rectangle, okay? And elevation is going to be up from the horizontal. Depression is down from the horizontal. But one thing that's interesting is that these two angles are equal to each other because they're alternate interior angles. Remember, you learned that in the first semester. And you can also think of this as h and this is 100 because this forms a rectangle. Okay, so it says that the angle of depression is 20, so that's this guy here. Remember, these are the same, so that's 20 and 20. What trig function ties together this angle, this side, and this side? Well, again, remember, if we position our guy right here, we've got opposite, and we have next to adjacent, so that is TOA, that's the tangent. So this is going to be the tangent of 20 degrees equals opposite over adjacent. And if I multiply both sides by 100 to get h by itself, I get 100 tan 20. And you can see that's going to be letter B is going to be the best answer for that one. So here it's like in calculator ready form. Sometimes they do that on final exams just so, you know, to give you some multiple choice options and makes it easier for your teacher to grade, right? Okay, so number 9, it says find out what this side is here, x. Okay, so again, we're doing more trigonometry. We position ourselves at the angle, the vertex where the angle is 55, and we say what trig function ties together opposite and adjacent. We're back to tangent again. So what do we have here? We have tangent of 55 degrees equals opposite over adjacent, multiply both sides by 4, and you can see it's going to be 4 times the tangent of 55. Let's see what that is really quick. And you can check, make sure I'm right, 5.7. Okay, so that's the approximate answer for this missing side. Now sometimes, I'll just give you a quick note here. Sometimes what will happen is you'll have tangent of, I'll just say 23 degrees, and you'll have like 4 over a, something like that. What I would do in a situation like this is I would think of this as being divided by 1, and what you can do is you can cross multiply. So you could say a times the tangent of 23 equals 4 times 1. Then you just have to divide to get a by itself. So I hope you're enjoying this so far. If you're preparing for the ACT or the SAT, which, you know, geometry plays a big part in that, check out my 2 courses, my huge ACT Math Review video course or my huge SAT Math Review video course. I've got 3 free lessons that you can take a look at and get a head start with that. And if you're interested, you can go on and get the course. A lot of students have taken it. They've told me that it's boosted their score on the exams, and I'm sure you'll benefit too. So check those out. If you're interested in individual private tutoring, whether for your math class or for a final or to prepare for these important ACT or SAT math sections, you can reach out and contact me. I'll have my contact information in the description of this video. But let's keep going with this video and make sure you do well on the final exam for geometry. Okay, question number 10, it says find the measure of angle x. Okay, so we're still working with trigonometry here, but what we're doing in this problem is we're solving for the missing angle. So whenever you're solving for the missing angle, you want to use your inverse trig functions like sine inverse, cosine inverse, tangent inverse. So what I'm going to do here is I'm going to say what trig function ties together opposite and hypotenuse. So opposites across, hypotenuse across from the right angle. Well, we know that's sine, right? So the sine of x equals 4 over 9. But to get the angle by itself, what we have to do is take the sine inverse of both sides. So we get x equals sine inverse of 4/9, or some people that are watching this video know it as arc sine. Okay, so x equals arc sine of 4/9 or sine inverse of 4/9. Let's go to the calculator on that one and see what we get. So sine inverse of 4/9, I'm getting 26.4 degrees. So that's going to be the measure of that angle right there. Okay, let's go to number 11 now. Now, number 11, it says, quote, solve the triangle. Now, what does that mean when they say solve the triangle? Well, it means you want to find all the sides, all the angles. It means you completely solved it. You found everything. Okay, so when we look at this triangle, we can see it's a right triangle. We have 2 sides. We can find the third side by using Pythagorean Theorem, right? So we've got a squared plus b squared equals c squared, or I'm going to say 5 squared plus 9 squared equals ab squared, right? So this is 25 plus 81, which is how much? Let's see, 25 plus 81, which is 106, right? So that's 106 equals ab squared. But we don't want ab squared, we just want ab, so we're going to take the square root of both sides. Now, let me just see really quick. So this is actually not going to be able to be simplified at all. So we can just leave this as an exact answer, square root of 106, and that's that side right there. Now we want to find the measure of angle A and the measure of angle B. Well, again, what I think I mentioned earlier in this video is that if you want to solve for the missing angle, you're going to have to do, you know, the sine inverse, cosine inverse, tangent inverse. But what you might want to do is go back to use the original figures that they gave you, if possible, to get a more exact answer. So what I would do here is I would say opposite and adjacent, that's tangent. I want to solve for the missing angle, so let me use my tan inverse, or you could think of it as the arctan. A lot of teachers say it that way. So let's do the arctan of 5 divided by 9. Check my work on this. I'm getting about 29 degrees. I'm rounding a little bit here, but 29. Okay, so that's angle A. But if we want to find angle B now, we know all the angles in a triangle add up to 180, right? But because this is 90, that means these 2 angles have to add up to 90. They're complementary. So if I do 90 minus 29, what does that come out to? 61 degrees, and you got it. So you solve the triangle. So that's a good question. Now, number 12, they're giving us now, we're switching from triangles to quadrilaterals. Quad means 4, right? And in a quadrilateral, all the angles add up to how much? In triangles, they add up to 180. Quadrilaterals, they add up to 360, right? So all we have to do now is recognize that when you see this square, that means it's a 90-degree angle. These are adding up to, let's see, 248. So that's 248. So all we have to do is say 360 minus 248, which is how much? Let's see, that's 112, so 112 degrees. Okay, let's go to number 13. It says find the interior and the exterior angle of a regular decagon. Now, what does it mean when they say regular? Well, regular means that all the sides are the same, all the angles are the same. That's what regular means. And decagon is like decade, 10 years in a decade. That means there's 10 sides. So there's a couple different formulas we can use here. One formula is we can use 360 divided by n. That's the measure of the exterior angle in a regular polygon. Or we could use this formula, n minus 2 times 180, which gives you the sum of all the interior angles. But if you divide it by how many you have, that'll give you the measure of the interior angle. So two formulas you might want to write down and memorize. But let's use this one here first. So let's see. So basically 360 divided by 10, since it's a decagon, would give you an exterior angle of 36. And if we want to find the interior angle, we can use this formula, but I'm going to show you a shortcut. See, take a simpler polygon to draw, like say, for example, like a hexagon. See, if you know the exterior angle, the one on the outside, how much do you think that interior angle is going to be? Well, see how they form a straight line? They're supplementary, they're a linear pair. That means if you take 180 minus 36, that's going to give you the interior angle. In this case, it's going to be 144. But you can double check your work with this formula if you want. I find this one to be a little bit easier, but they'll both work. Okay, number 14. It says, given parallelogram ABCD, find X, Y, and Z. Okay, so now what they're testing us on, we kind of moved over to quadrilaterals in this section. But what we're talking about are parallelograms. So just a quick review. This is what you want to know about parallelograms. The opposite sides are congruent. The opposite sides are parallel, right? The diagonals bisect each other. They cut each other in half. The opposite angles are congruent. And the consecutive angles are supplementary, meaning the ones that are next to each other add up to 180 degrees. So those are some of the properties of parallelograms. And so here what we're going to do is we're going to say, well, let's see, opposite angles are congruent. So that means this whole angle and this whole angle are going to be equal. So let's make an equation and solve for y. So 3y plus 12 equals 120. Subtract 12, that's 108. And divide everything by 3, y is 36, right? So that's going to be y. Okay, now let's go to x. So now here you can see these diagonals, they're cutting each other in half. That means that this portion and this portion must be equal to each other. So let's set these equal. So we've got 2x minus 4 equals x plus 8. Subtract x from both sides, right? That's going to give you x minus 4 is equal to 8. Add 4 to both sides, and you get x equals 12. Okay, that's good. And then let's see z. The opposite sides in a parallelogram are congruent, so I can set these two equal to each other. So let's see. So that's going to be what? Let's write it over here. We've got 5z minus 2 is equal to 3z plus 8. 3z plus 8. So if we subtract 3z from both sides, we get 2z. If we add 2 to both sides, we get 10. If we divide by 2, we get z equals 5. And you can double check your work by putting it back in. You know, this would be 25 minus 2 is 23. 15 plus 8 is 23. You can see that they're congruent. Okay, question number 15. It says, for what value of x is the quadrilateral a parallelogram? So remember, you know, one of the properties of parallelograms is that you want the consecutive angles, meaning the ones right next to each other, one after another, not the opposite angles, but the ones next to each other. You want those to be supplementary. So in this case, you can see 115 plus x has to add up to 180, which means that x must be 65. And what's interesting is that if these are supplementary, that means that these lines are parallel, okay, because of that consecutive interior angles converse theorem. And then if these are adding up to 180, because 115 plus 65, that means that these two sides are parallel by the consecutive interior angles converse theorem. And so that you now have two pairs of opposite sides parallel, and it's a parallelogram. But the key is you want, you know, these two to add up to 180, these two add up to 180, the consecutive angles are supplementary. Okay, now number 16 says, which of the following can be proved a parallelogram? Okay, we've got A, B, and C. Okay, now remember, we talked about some of the properties of parallelograms earlier in this video, but to prove that a quadrilateral is a parallelogram, there's a lot of different ways to do it. So let's see if I can maybe write some of them down here. Okay, you can show that both pairs of opposite sides are parallel. Okay, that's the definition of a parallelogram. You can also show that both pairs of opposite sides are congruent, has to be both pairs. You can show that the diagonals, they bisect each other, they cut each other in half. You can show that both pairs of opposite angles are congruent. Okay, so these are congruent, the ones that are across from each other are congruent. again, you can show like we were doing over here where you have, you know, these angles are supplementary, these angles are supplementary. And here's the one that most students tend to forget, and I'm sure your teacher will probably test you on this, is that you can show that one pair of opposite sides are both parallel and congruent, whether it's these two sides or whether it's these two sides. You show that they're the same length and they're parallel. Okay, so let's take a look. So this one is what we just talked about right here. So that one can be proved. We'll just write yes, okay. This one, you've got one pair of opposite sides parallel. These opposite sides are congruent, but they're not the same two sides that are parallel and congruent. So this one is no. And then this one, you can see that the diagonals are cutting each other in half. This half is equal to this half, that half is equal to that half. Both diagonals bisect each other. So this one is yes, it can be proved a parallelogram. So these are the different ways to prove a quadrilateral is a parallelogram. Number 17, it says, which of the following may not be true for a parallelogram to be a rectangle? May not be true. Okay, so now we're switching over to rectangles. So a parallelogram just means that, you know, it has all the properties of a parallelogram. Both pairs of opposite sides are congruent, diagonals are bisect each other, and so forth. But in a rectangle is a parallelogram with the added property that the diagonals are the same length. Okay, so that's one of the properties of rectangles. So this one is true, but we're looking for which may not be true. 4 right angles. Well, that's another property of rectangles. It's a parallelogram with 4 right angles, so that's a rectangle. Okay, so that's not out. We're looking for the one that doesn't work. The diagonals bisect the opposite angles. Well, now that's true in a rhombus. See, a rhombus is a parallelogram, and additional properties that the diagonals are bisecting or cutting the opposite angles in half. But that's not necessarily true for a rectangle. And one way to kind of prove this to yourself is to draw like a really long rectangle like this and then draw a diagonal. You can see that this angle is much smaller than this angle. So you can see that that's not true. So that's a good counterexample. So it looks like it's letter C, but let's check letter D. Opposite sides are congruent. Well, that's one of the properties of a parallelogram, but it doesn't necessarily prove that it's a rectangle. So that's out. So it's letter C. Okay, let's look at number 18 now. Given isosceles trapezoid ABCD, find the length of BD. Okay, now what's an isosceles trapezoid? Well, a trapezoid, just to refresh, means that one pair of opposite sides are parallel. Whereas a parallelogram, you have both pairs of opposite sides are parallel. But what makes it isosceles is, in addition to just having one pair of opposite sides parallel, the two legs or the two sides are congruent. And there's all kinds of neat properties when you have an isosceles trapezoid. The base angles are congruent. See, these two and these two. Let's see, the diagonals are the same length. Okay, they don't bisect each other or cut each other in half like in a parallelogram, but they are the same length in an isosceles trapezoid. These angles are going to be supplementary, and these two angles are going to be supplementary because those are consecutive interior angles. So a lot of neat properties with the trapezoids, but in this example, they're giving us this diagonal is 9, which means that we know that BD is also 9. Okay, so don't get distracted by some of the other numbers here. Okay, now number 19, it says, given trapezoid WXYZ, that's this guy here, with midsegment RS is 15, XY is 8, find the length of WZ here on the bottom. Okay, so what they're testing us on in this question is the midsegment theorem. And what the midsegment theorem says is that if you have a segment that connects the two midpoints, and we know it's the midpoint because these are congruent, so that's a midsegment. This midsegment is the average of the two bases. So you could say base 1 plus base 2 divided by 2 equals your midsegment, okay? So in this case, let's use that equation. We're going to say x plus 8 divided by 2 is equal to 15, right? Multiply both sides by 2, and you get x plus 8 is equal to 30. Subtract 8 from both sides, and you get x is 22. And you got it. So again, remember midsegment theorem, it's like the average of the two bases. You add those up, divide by 2, that's your midsegment. So are you enjoying this video so far? Are you learning something? Subscribe to the channel if you haven't subscribed already. And let's keep going with this video. So it says, given kite ABCD, okay, this kite here, it says find the measure of angle D. Okay, so we're talking about kites, and you know what's interesting about a kite is that it's just like what you think of when you think of a kite. You know, you have two pairs, okay, of consecutive sides congruent, and you've got a line of symmetry that goes right down the middle like this. Okay, so if you fold it over that line, you know, this angle and this angle are the same, this angle and this angle are the same. All kinds of neat properties about kites. You know, the diagonals are perpendicular, they form right angles. But again, if we go to that concept of thinking of this line here as a line of symmetry, when you fold it over, see this angle A 110, angle C will be exactly the same. It's also going to be 110. So in a quadrilateral, all the angles add up to 360. Just like in a triangle, all the angles add up to 180. So if we add all these up, let's see what we get. We get 100, 200, 300, 40. And if we subtract, let's see, so that means that this would make this 20 degrees because they have to add up to 360 degrees. So that's the key, is folding it over that line of symmetry. You know, this segment and this segment are going to be the same. You know, one thing you want to realize though is that this diagonal, when you fold it over that diagonal, that's not a line of symmetry. Okay, let's look at number 21. It says, what is the most specific name of quadrilateral LMNO? Okay, well, what's interesting here is that you can see that the diagonals are bisecting each other. That proves that it's a parallelogram, but we want to get more specific than that if possible. And we also know that if the diagonals are the same length and it's a parallelogram, that means that it's a rectangle. So the most specific name that we can go with this one is not just parallelogram, not just quadrilateral, but rectangle. And that's you got it. Now we don't know that all the sides are congruent, so we couldn't say that it's a square. But we definitely can say it's a rectangle. So number 22, it says a quadrilateral has two pairs, okay, two pairs of consecutive sides congruent. What types of quadrilaterals meet this condition? And there could be more than one answer, right? So when they say consecutive, that means like one after another, right? So as opposed to the opposite sides, these are the consecutive, one after another. So we can see that it's going to be true for a kite. See, a pair means these pair, like a two, like a pair of shoes. And there's two pairs. So this is a pair, two pairs of consecutive sides congruent. So we know kite is one of the answers. What else? Well, we also know, let's see, how about like a rhombus? A rhombus, all the sides are congruent. So you have these two pair are congruent and these two pair are congruent. So that would work. Let's see, how about for a square? Same thing for a square. You know that these are the same, these are the same. Okay, so those three would be pretty good. So I think that's going to wrap that one up. Now number 23, they give us this big diagram. I'm sure you're going to have something like this on your final exam where they're going to have you name all the different parts of circles and so on. So let's see if we can do this one. So line AB, now notice the line above it, that tells us it keeps going. So AB, this line AB, what do you call that? What's the name for that? Well, you can see it just touches this circle at one point. It just touches this circle at one point. It's a tangent, but it's actually tangent to both these circles, so we would call this a common tangent. Now, it depends on your book, but some books will even take it one step further and say that this is a common external tangent. Internal tangent means it would go in between the two circles, kind of like something like this, okay? That would be a common internal tangent, but this is external. Now segment DE, let's see, where is that? So here's DE, so it starts at D, ends at E, it goes through the center. What's the best name for that one? Diameter, right? Diameter. Okay, how about for point P? Let's see, where is point P? Let's change this to B, okay? So how about for B? Well, this B is actually called the point of tangency, okay? Point of tangency. That's the point where the line just barely touches the circle at that one point. So point of tangency would be the best one there. Segment EF, okay, that's from here to here. That's a chord. Now remember this problem we did with the diameter. This is also a chord. It's the longest chord in a circle, but because it goes through the center, we call that a diameter. Line TU, let's see, where is that? TU, okay. It keeps going. It's not like a chord where it starts at T and ends at U. It keeps going and cuts through the circle at 2 points. That's actually called a secant, right? S-E-C-A-N-T, secant, right? Segment CE, that starts at the center, ends at the point on the circle. That's a radius, right? Radius. Point C, that's the center of the circle. So I'll just write center, okay? And that's it, you got it. So that's naming the different parts of a circle. Now for number 24, it says L is a point of tangency. Okay, this is point L right here. This is M, this is N. So it's a point of tangency. Find the radius X, that length. Okay, now what's interesting is when you draw a radius to the point of tangency, what kind of angle is formed right here? A right angle, right? Now what's also interesting here, and they don't draw this on the diagram, but you see how this is X, and this is also going to be X, because these are both radii. From here to here is the radius, from the center to this point on the circle, that's a radius. But now notice what we have coming into view here. That's a right triangle, and we know that we have a right triangle, we can use Pythagorean theorem. So let's go ahead and set that up. So we've got a squared plus b squared equals c squared. Remember the one across from the right angle, that's our c side. So we've got x squared plus 12 squared equals x plus 8 squared. I had to add these two together to get that total length, so we want to square that quantity. Now here's where students go off the track, and I don't want you to go off track here. What students will do is they'll just distribute that 2. Now you can't do that because this is a binomial. You actually have to FOIL this out. So it's really going to be like x plus 8 times another x plus 8. And if you FOIL that out, you get x squared plus 16x plus 64 equals x squared plus 144. Now if you subtract x squared from both sides, those cancel out. If you subtract 64 from 144, you get 80 equals 16x. And if you divide both sides by 16, you can see that x is going to be equal to 5, and that's your radius. Okay, everybody hanging in there? This is a good review. We're covering a lot of important concepts. So in this problem, number 25, what we have is we've got a point outside the circle, right? And you've got 2 tangents drawn to the circle. And what do you know when you have a point outside the circle and 2 tangents drawn to the circle, one above, one below? Well, we know that those 2 lengths are going to be congruent. Now this one means, or asks us to find the length of AB, right? But what we have to do is we have to set these equal to each other first to find out what x equals, okay? A lot of times students solve and they find out what x is, but they don't take it one step further and put it back in to find the length of AB. So let's solve this. We're going to subtract 3x from both sides. We're going to add 2 to both sides. We're going to divide by 2. X equals 5. Some students will mistakenly put 5. But what you want to do is you want to put it back in here. That's going to be 3 times 5, 15, plus 2 is 17. You can double check it. 25 minus 8 is 17. So you can see both of those tangents are the same length. Okay, number 26, they give us a circle here. And it asks us to find the measure of, measure of angle C. This actually should be the measure of arc AC. Okay, that's the measure, meaning how many degrees is that arc. Now notice there's only 2 points here. That means that this is a minor arc, which means we know that it's going to be less than 180. But what's interesting is if they give us the central angle 50, that arc that it intercepts is also going to have a measure of 50. So if that's the central angle, this angle and this arc measure are going to be the same. So that's going to be 50 degrees. Now the measure of, let's see, arc LEM. Okay, so where is arc LEM? So that's here to here to here. Okay, so notice it's going to be, it's a major arc or a semicircle when you have 3 letters like that, and it's telling you to go from L to M through point E in between L and M. But one thing you want to notice here is that if this angle is 40, see how these 2 form an X, these 2 line segments, these 2 chords? The angles across from each other, those are going to be congruent. Those are vertical angles. And so what we can do is we can say this is like a diameter. So I'm going 180 degrees plus an additional 40 degrees. That's 220 degrees. Okay, and then the measure of arc CE, that's this guy right here. Well, again, you can see that this is a diameter, okay, LE. If this adds up to 90, that means that this must add up, this must be 90 because they have to add up to 180 degrees because of that straight angle. So the measure of arc CE will be the same as that central angle, 90 degrees, and you got it. So again, what I recommend when they give you a diagram like this, is jump into the diagram, try to fill out what you know, and then you can go back and then this will make it a little bit easier. So you don't have to remember it all in your head. Okay, number 27, another circle diagram. And let's see, it says the measure of arc XZ, okay, and the measure of arc TZ are the same. Okay, so they're saying that this arc and this arc are the same length. Now, when you see that the arcs are the same length, that means that the chords that intercept those arcs will also be congruent, and vice versa. If the chords are congruent, then the arcs that they intercept are congruent. Does that make sense? So now we say if xy is equal to 4, so if this is 4 right here, right, then what's the length of TZ? Well, here's what's interesting. When you draw a radius perpendicular to that chord, it's going to bisect the chord, okay? So that means that this is 4, which means that this whole chord is 8. This chord will also be 8. Okay, good. Now let's see over here. It says if the measure of arc XZ equals 150, okay, now I'm just going to erase these because we're going to start fresh on this problem. So if this is 150, find the measure of arc XT. Well, remember, if these arcs are congruent, that's 150, that's 150. How much is this arc right here? All the arcs in a circle add up to 360 degrees, right? So this is 300. That means that this must be 60 because they have to add up to 360. And then part C says if WY equals X plus 1, okay, so this little piece right here, X plus 1, and WR, this little piece right here, is 2x minus 3, find the length of WR. Now here's the thing. Let me see if I can draw a little picture here. basically, here, I'll draw it right here. So basically, if the chords are the same length, okay, what that means is that they're the same distance from the center, the perpendicular distance, the shortest distance. So that's the idea. So because we know that these arcs are the same, we know that the chords that intercept those arcs are congruent. If the chords are congruent, that means they're the same distance from the center. So all we have to do is set these equal to each other. So let me do that right here. So 2x minus 3 equals x plus 1. Subtract x, add 3. You can see x equals 4. And if we put that back in, that's going to be 2 times 4 is 8 minus 3 is 5. And you can double check it. You know, that's going to be 4 plus 1 is 5, right? Okay, so very good problem. Number 28. It says if AB is equal to 8, so they're saying the length of this chord is 8, and FD is 3, okay, that's right here, this is 3. Find the radius of circle D, okay, this is circle D. Okay, now this is very interesting because you see how they're drawing this diameter perpendicular to this chord? That means that it cuts the chord in half, okay, it bisects the chord, it also bisects this arc over here. Okay, so that means that if AB is 8, that means that this length right here is 4. This length over here is 4. Now what it wants is the radius of the circle, which would be like DE. They don't draw it in the picture, but what you can do is you can draw what they call an auxiliary line. You know, you draw on your own line from D to B, for example. Now look what we have. We've got a right triangle, also a Pythagorean triple, 3, 4, 5. So the radius is going to be 5. Okay, so see how I did that? So remember the diameter, if it's perpendicular to the chord, it cuts the chord in half, it bisects it. Okay, it's at a right angle here. We just had to draw on that line and do the Pythagorean theorem and we got it. Okay, number 29, what we have is we have two chords that intersect. And what happens when they intersect is they divide each other into two parts or two pieces, right? Or two segments. And what's interesting is that the product of these two segments is equal to the product of these two segments. So 4 times x is equal to 3 times 8, which is 24. Divide by 4, x is equal to 6. Okay, so you're with me on that one? So another way to write it, a lot of times when I explain this to students, I say, well, just think of this as A and B. This is C and D. A times B equals C times D, and that's the property. Okay, number 30, it says find x. Okay, so what we have here is we have two secants. Okay, it's cutting through the circle at 2 points. And what you want to do for this one is you want to take the whole length, okay, which is going to be 8, times the external portion, the part outside the circle, equals this whole length, which is x plus 4, times the part outside the circle. So the way I always like to explain it to students when I'm tutoring them is I say whole times external equals whole times external. It's easy to remember, right? So now let's just simplify. Let's do the algebra. So that's going to be 24 equals 4x plus 16. I'm just doing the distributive property. And if you subtract 16 from both sides, okay, you've got that. And then if you divide by a 4, you can see that x is equal to 2. It wants to know the length of x. We put that back in. That's 2. My drawing's not drawn to scale, but sometimes that's how it works. On my Mario's Math Tutoring YouTube channel, I've got a playlist, a geometry playlist, which has a lot of different videos covering all different aspects of geometry. So if you're looking for additional help beyond this video, you can go over there and check out that playlist to go through it and see what other topics you want to learn more about. But let's keep going with this. So number 31, what they're giving us here is they're giving us a secant and they're giving us a tangent. So remember the formula. Remember in the last problem we did the whole times the external equals whole times external. Well, in this case, we're going to take the whole times the external equals the tangent squared. Okay, so that's the key. So the whole length here is 9. The external part, meaning the part outside the circle, is 4, equals the tangent times the tangent, or the tangent squared. So we get x squared is equal to 36. Take the square root of both sides, and you can see x equals 6. Okay, number 32, what they have here is they're giving us an inscribed quadrilateral. So scribe means to draw right, in means on the inside. The vertices are just barely touching the edges of the circle. But what's interesting in this scenario is that the angles that are opposite one another are supplementary, okay, meaning they add up to 180. So here what we can do is we can solve some equations. We can say, well, let's see. We want to solve for x and y. So 110 plus x equals 180. So that means that x equals 70. And over here we have y minus 5 plus 92 equals 180. So let's write that equation. Y minus 5 plus 92 equals 180. So let's see, that comes out to what, 87, right? Subtract the 87, and what does that come out to? Is that 93? Yeah, 93. Okay, so that was a good one. So opposite angles are supplementary. Number 33, it says find the measure of arc xz. So we're trying to find out how many degrees is this arc right here. Okay, well now what's interesting here is we're starting to get into some other problems here with circles, but what you have is this formula here. I'll see if I can kind of show you. What you have is you have an external angle, exterior angle, this angle 1, and what you do is you take these two arcs that it cuts off or intercepts. I'm going to call this arc A and this arc B. The measure of angle 1 is equal to A minus B divided by 2. Okay, so it's the larger arc minus the smaller arc divided by 2 equals this exterior angle. The only problem is that let's go ahead and call this arc right here x, since that's what we're trying to solve for. That means that this arc over here must be 360 minus x, right? Because they all have to add up to 360. So now what we're going to do is we're going to take this larger arc, which is x, minus this smaller arc, which is 360 minus x, all divided by 2 equals this exterior angle, which is 48 degrees. Okay, so you're with me? So now what we're going to do is we're going to multiply both sides by 2 to get rid of the fraction here. I'm going to distribute the negative, so that's going to be negative 360 plus x. So now we have 2x minus 360 equals 96. Add the 360 to the other side, which equals how much? Let's see, that would be, 456? 456. And then divide both sides by 2, and the x is equal to 228. So check my math on that one. If I'm wrong, put a note in the comment sections for other people that watch this video, but that should be right. So basically you're taking the larger arc minus the smaller arc divided by 2 equals the exterior angle. Now we're getting into the equation of a circle, and the standard form for the equation of a circle is this guy right here. It's x minus h squared plus y minus k squared is equal to the radius squared. H comma k is the center, and then the r is the radius. So in this case, all we have to do is substitute. We've got x minus a negative 3, which is like x plus 3, and y minus positive 1, so y minus 1 squared, and 5 is the radius, so if we square that, 5 squared is 25. So that's the equation of our circle in the standard form of the equation of a circle. Number 35, it gives us the point 1, negative 9 is on a circle with the center at 4, negative 5. Write the standard equation of the circle. So a little bit of different variation here. The center is at 4, negative 5, so that's x minus 4 squared plus y plus 5 squared equals the radius squared. One thing you'll notice is that these numbers here are always the opposite sign, right? So this is actually positive 4, negative 5. See the center? Because you're subtracting. But what we have to do is we have to find out what r squared is here to complete this equation. But they give us a hint. They tell us that the point 1, negative 9 is on the circle. So I'm going to put 1 in for x, negative 9 in for y, and then we can solve for r squared. So 1 minus 4 is negative 3. Negative 3 squared is 9. Negative 9 plus 4 is negative 4. Negative 4 squared is 16. So you can see that r squared is equal to 25. All we have to do is put that back in, and we've got our equation. Now that's one way to do it. The other way to do it is you can do the distance formula, okay, and find the distance from the center to the point. That's your radius. Then just put it in here and square it, and that's your equation. Okay, number 36, it says find the area of the parallelogram. Well, what's the formula of the area of a parallelogram? It's just base times height. So here's the base, and the height is this perpendicular distance between the two opposite sides, the two bases. So this is going to be 6 times 3, which is just 18 centimeters squared. They put this 4 on here to test you. You know, sometimes it's to distract you a little bit. Some people might think 6 times 4. That would be fine if it was a rectangle, like length times width or base times height. But here what we want is that perpendicular height. Okay, now number 37, they give us a triangle, perimeter and area of the triangle. Now remember, earlier in this video we were talking about Pythagorean triples. And as you work with Pythagorean triples more and more, these will start to jump out at you. So we know 7, 24, 25 forms a right triangle. That's a Pythagorean triple. If we double all these, we get 14, 48, and 50. So you say, oh, well that means that this must be 48 then, 14, 48, and 50. Okay, so now if we want to find the perimeter, we just have to add up all the sides. That's the distance all the way around. So what does that come out to? That's 98. That would give us 112, right? So 112 inches. And then the area of a triangle, remember it's 1/2 base times height. This is the base, that's the bottom, that's what it sits on. That's the height, that's how tall it is. A triangle is like a mountain, right? So you measure straight down. So that's going to be 1/2 48 times 14, right? Now you can multiply these in any order. I'm going to do 1/2 times 14 is 7. Then I just have to figure out what 48 times 7 is. Sometimes your teacher has no calculator section. So let's see, that would be 28 plus 5, which gives you 33. So this would be 336 inches squared. And you can check my work on that one, or you can check it on your calculator real quick. Here, I'll just double check, make sure we got the right answer. 336. Okay, cruising right along, number 38. It says the area of the trapezoid is 36 meters squared, find x. So what they're testing us on in this question is, do we remember the formula for the area of a trapezoid? And I'll just write it down here for us. So it's 1/2 the height, which is 4, okay, that's the distance between the two bases, times base 1, which is x, plus base 2, which is 12. So the bases are the two parallel sides. Now they tell us that the area is 36, so I'll put that in there. So all we have to do is simplify. So we get 1/2 of 4 is 2. Divide both sides by 2, that gives you 18 equals x plus 12. Subtract 12 from both sides, and you can see that x is equal to 6 meters. And make sure you put your units if there's units in the problem, right? Number 39, it's talking about the area of a rhombus. Now, the nice thing about rhombus and kite is that they have the same area formula, so it's one less thing to memorize, right? You just have to remember area equals 1/2 diagonal 1 times diagonal 2. So in this case, they're only giving us this piece is 2, but in a rhombus, we know that the diagonals bisect each other. So this is actually going to be a length of 6. The other diagonal is a length of 4, and we do 1/2 6 times 4. So let's see, that's 24. Half of 24 is 12 units squared. Okay. Number 40, it says if the area of a kite is 72 centimeters squared and one diagonal is 24 centimeters, what is the length of the other diagonal? Well, again, remember, it's the same formula for rhombus and kite. So let's put in what we know. I like to write down my formula first, and then right underneath it, I like to substitute in what I know, and then I can always solve for what I don't know. I'll just put that x for diagonal 2. So half of 24 is 12. Divide both sides by 12, you can see that x is equal to 6, and in this case it's centimeters. Okay, number 41, they're giving us two similar polygons. Now remember, similar polygons, the corresponding angles are congruent, but the corresponding sides are proportional, right? And it says A and B, they have a scale factor of 2 to 3. Okay, they give us the perimeter and the area of the smaller one. They want us to find the perimeter and the area of the larger one. Well, here's the thing. If you know that the scale factor is 2 to 3, the ratios of the perimeters, see, perimeter is just like length, will be the same as the ratio of the side lengths. So it's also going to have a ratio of 2 to 3. So if the perimeter of the smaller one is 25, we can solve for the perimeter of the larger one. Now notice when I set up this proportion, I did small to large. See, 2 is smaller than 3, so small to large. I did the perimeter of the small figure to the large figure. See, small to large, small to large. You want to keep that consistent. Then you cross multiply on the diagonal, right? So 2p equals 75, divide by 2, that's 37.5, whatever the units are. We'll just say units. Now for A, for the area, here's where students sometimes get a little bit off track. If the scale factor is 2 to 3, right, 2 to 3, you have to square that to get the ratio of the areas. If it was a three-dimensional figure, you would cube the scale factor to get the ratio of the volumes. So if we square this, we square the numerator and the denominator, that's going to give you a 4 to 9 ratio. And the area of the smaller one is 43. We just have to find the area of the larger one. See, small to large, cross multiply on the diagonal, we get 4x equals 9 times 43. So I'm going to go to the calculator here just to make sure I don't make a little arithmetic error. That's 387. And we just divide both sides by 4, and that comes out to 96.75 units squared since it's area. Okay, now number 42, what we want to do is find the area of this octagon. Notice it's a regular octagon, all the sides are congruent, and it looks like a stop sign, right? But remember, when you find the area of a regular polygon, this is the formula you want to memorize, 1/2 apothem times perimeter. Okay, the perimeter is easy to figure out. You just add up all the sides. In this case, it's 10 times 8, okay, which is going to be 80. But the apothem, what's that? Okay, it's kind of a weird kind of name, but what it is the perpendicular distance from the center to the side. Now, what happens when you draw that perpendicular is it bisects the side, it cuts it in half, and so now each of these are going to be 5. But what we have to do now is we have to find out what that central angle is. Well, the thing is you can divide up an octagon into if I can draw this for us here, whoops, I'm missing the vertices here. You can draw it like this. You can divide it up into 8 congruent triangles. So if you take 360 divided by 8, that gives you the central angle of 45 degrees. So that's this angle right here. But then if we bisect it, we're cutting it in half. So let's see if I can draw this triangle a little bit larger for us so we can see what this looks like. So this was originally 45. We bisected it. That means that this is 22.5. This is our apothem. It's the height of the triangle. And this is 5. Okay, so what we're going to do now is we're going to ask ourselves what trig function ties together this angle, this side, and this side. Well, we've got opposite and we have adjacent. That's tangent, right? So the tangent of 22.5 equals opposite over adjacent. I can cross multiply. A times the tangent of 22.5 equals 5 times 1, which is 5. Divide both sides by the tan of 22.5, right? Like that, both sides. And let's see what that comes out to. So 5 divided by the tan of 22.5. It's 12.07, okay, if I round. And all we have to do now is multiply all that together. So if I do that, 12.07 times 0.5 times 80, it looks like I'm getting 482.8 units squared. So remember the formula for a regular polygon, 1/2 apothem times perimeter. So if you like my teaching style and you're preparing for the ACT or the SAT, the math sections, check out my 2 courses, my huge ACT math review video course and my huge SAT math review video course. I go through a teaching section, we go through example problems, we go through formulas, we go through different ways to approach the problems and recognize the problems so that when you take that test, you're going to be better prepared to score well. So there's 3 free lessons in each of those courses that you can take and get some experience with the course, benefit from that. And if you want to go further, get the courses. And a lot of students have already taken the courses and reported back that they've improved their scores. I'm sure you will too. So check those out. If you're interested in private tutoring with me, I have a busy schedule, working with in-person students, but I do have some online students, and if I have availability, I'd be happy to help you, whether prepare for the ACT, SAT, or your math class, a final, whatever it is that you're working on. Feel free to reach out to me. Also, check out more math videos on my YouTube channel. I've got a ton of information there that can benefit you as well. But let's keep going with this video and make sure that you're ready for your geometry final. So number 43, they're giving us a circle, and they're asking us for the circumference and the area. So there's a lot of formulas, in math that you have to memorize. In this case, the circumference is pi times diameter, or you could say 2 pi r. But in this case, since they're giving us the diameter is 12, I'm just going to say 12 pi. That's an exact answer, and that's going to be meters. Now, if you wanted to round to the nearest tenth or hundredth, then I would put in 3.14 for pi and multiply. Area, now the formula for area you want to memorize is pi r squared. I think of a circle as like a pizza pie, like, an apple pie. Pies are square. No, they're actually round, right? But here what we have to do is we have to cut the diameter in half to get a radius of 6, and then do pi times 6 squared, which is 36 pi, and then it's going to be meters squared since it's area. Okay, number 44, they want us to find the length of arc AB, not the measure. The measure would be 120 degrees, but the actual length, if we were to straighten that out. And they want us to find the area of the sector. Okay, so length of AB first. Well, there's a couple different ways to do this problem. I'm going to show you this way first. 120 divided by 360, okay, that's the fraction of this angle to the whole circle, 360, equals the arc length, which I'm just going to say arc, is to the entire circumference, which is 2 pi r, which in this case would be 8 pi, 2 times pi times 4. Then all you have to do is cross multiply and solve. What you might want to do first is reduce this. This reduces to 1/3. Then when you cross multiply, you get 3, I'm just going to say a for arc length equals 1 times 8 pi. Divide everything by 3, and so you're getting 8/3 pi inches. Okay, that's an exact answer. If you want an approximation, put in 3.14. Now for the area of the sector, you can do the same thing, make a proportion. The other way to do it is, though, you can say 120 divided by 360 is 1/3, so we're actually taking 1/3 of pi r squared. Pi r squared is the whole circle. We just want the fraction of the whole circle. Of means times, right? So this is 16 pi times 1/3, which is 16/3 pi inches squared. That's an exact answer. Okay, number 45, it says, how many vertices does a pentagonal pyramid have? Well, let's see if we can draw it. So basically, a pentagonal pyramid means it has a base that's a pentagon, right? And it goes to a vertex up here. So the vertices are the points. It's where the edges come together. So I'm counting 1, 2, 3, 4, 5, 6. There's 6 vertices, 6 points. Okay, the edges would be like these segments, okay, and the faces would be in this case, the triangles and the pentagons, the polygons that make up the three-dimensional figure. Number 46, it says, which are polyhedrons? Poly means many, and hedron means like, sides or faces, right? But the thing is, in order for it to be a polyhedron, a three-dimensional polyhedron, all the faces, all the sides have to be made up of polygons. What's a polygon? A polygon is an enclosed region, okay, one enclosed region that it's made up of line segments. So for example, I drew a pentagon here, but I could have drawn a square, or I could have drawn a triangle. For example, like this, that's not a polygon. See, it's enclosing two different regions. This is not a polygon because you can see there's a curved region right here. So this one, you can see the circle, that's not a polygon, so this is not a polyhedron. This one's a triangular prism. This one is, yes. This one is a square pyramid or a rectangular pyramid. So this one is yes. You can see all the faces are triangles or squares. So those are polyhedrons. Now 47 says, given a polyhedron with 8 faces and 4 vertices, how many edges does it have? Now what they're testing us on this question is, do we remember Euler's formula? Okay, Euler's formula, or Euler's formula, however you want to pronounce it. Now the way I remember this formula is it's my favorite formula, my fave, right? FVE, my favorite formula. Faces plus vertices equals edges plus 2. Now the number of faces here are 8. The number of vertices are 4. We don't know the number of edges, but we can simplify this. 12 equals E plus 2. Subtract 2, there's 10 edges. Okay, so just remember Euler's formula, F plus V equals E plus 2. Number 48, what is the shape of the cross section of a plane cutting through a cone parallel to its base? Well, let's see if we can draw a cone. There's a cone. A plane is like a flat surface. It cuts through parallel to the base, which is a circle. Looks like we get another circle. Now, sometimes what you're going to get on your test is you might get like, for example, if it cuts through the vertex perpendicular to the base, then you would get like a triangle. Okay, so it depends on what angle. If you go on a diagonal like this, you would get like an ellipse or an oval, and so on and so forth. But basically, it's good to draw a diagram and then visualize what's happening with that one. So let's go on to the next question. Okay, we're getting near the end, just a few more problems to go. If this is benefiting you, let me know how you did on your final exam. Report back to this video, comment in the section below. I love to hear how students benefited from these different videos that I put together, so I know to make more, and just let me know in the comments. That would be great. Number 49 says the scale factor between two similar figures is 3 to 5. If the smaller figure has a volume of 81 inches cubed, what is the volume of the larger figure? Well, we talked a little bit about this earlier about scale factor between the side lengths and the surface areas and the volumes. What you want to do is you want to take that scale factor 3 to 5, and because it's volume, you want to cube it. So it's really going to be a ratio of 27 to 125, small to large, right? So in this case, the smaller figure has a volume of 81. We want to find the volume of the larger figure. So small to large, small to large. The key was we had to do this operation of cubing the scale factor to get the ratio of the volumes. Now we can make a proportion here. You can cross multiply and solve, or here's another little technique. 27 times 3 is 81. So if I multiply the numerator by 3, I have to multiply the denominator by 3. That's going to be 125 times 3, which is 375 inches cubed. Okay, let's go to number 50 now. So 50, what I did is I put together a diagram like this to kind of illustrate how this works with the scale factor. See, scale factor, you're comparing like the side lengths or the perimeters or one-dimensional components, okay, of the figures. Area, you're comparing like lateral area, surface area, two-dimensional components. Volume, you're looking at three-dimensional components, right? So the key is, are we dealing with 1, 2, or 3 dimensions? So if the scale factor is 1 to 2, and you're going from one-dimensional to two-dimensional, you have to square this. So that's going to be 1 squared is 1, 2 squared is 4. If you want to go from the scale factor, which is one-dimensional, to the volume, which is three-dimensional, you have to cube this scale factor. 1 cubed is 1, 2 cubed is 8. So you with me so far? But if they give you the ratio of the areas, that's two-dimensional. You want to go back to one-dimensional, you have to square root. So that's going to be square root of 9 is 3, square root of 25 is 5. Now if you want to go from one-dimensional to three-dimensional, surface scale factor to volume, we have to cube both of these. That's 27 to 125. And then here, if they give us the volume three-dimensional, we want to go back to the one-dimensional components. We have to take the cube root to go from 3 to 1. Cube root of 64 is 4. Square root of 729, I believe, is 9. Let me just double check really quick. 9 cubed. Yeah, 729, that's right. Now, if we want to go from the scale factor to the ratio of the areas, 1 to 2, we have to square this, which is going to be 16 to 81. So that's how you work back and forth. You just have to analyze it. Is it 1, 2, or 3-dimensional, and work from there. But it's easier to go back to the scale factor first, then square it to get the ratio of the areas or the volumes. Okay, let's go to number 51. 51 has 4 parts. We're finding surface area and volume of these 3-dimensional figures. So here's the thing. We've got a cylinder. The cylinder, the formula is, for surface area, it's 2b, 2 bases, plus the perimeter of the base, or the circumference of the base, times the height. So the base is a circle, so we have 2 pi r squared, plus the perimeter of the circumference, which is 2 pi r, times the height. So if we put in everything, we get 2 pi times 5 squared, which is 25, plus 2 pi, the radius is 5, the height is 10. We get 50 pi, plus 50 times 2 is 100 pi. So we're getting 150 pi inches squared for the surface area, the total area of the outside. The volume, the formula is a little bit easier. It's the area of the base times the height. So the base is a circle, so pi r squared times the height. So it's pi times 5 squared times the height is 10. So that's 25 times 10 is 250 times pi inches cubed. So these are exact answers. If you want to find a rounded answer, just put 3.14 in for pi. Now for letter B, they're giving us a a square pyramid, right? The base is a square, okay? So to find the surface area, you have to find the area of one base, not 2 bases like here we had 2, just one base, plus 1/2 the perimeter of the base times the slant height, the L, the leaning height. Well, they give us the leaning height as 5 here. See, that's the height of this triangle right here, that's 5. They give us the perimeter of the base, which is 6 times 4, so that's 24, times 1/2, and then the base here is 6 times 6, it's a square, that's 36. So if we add this together, that's half of 24 is 12, 12 times 5 is 60, plus 36 gives us 96 units squared. Now if we want to find the volume is the area of the base times the height times 1/3. Now when we're looking at the volume, we want this height here, the one from the vertex to the middle of the base, not the slant height. We use that L, that leaning height, that slant height for the surface area. So here what we're going to do is take the area of the base, which we figured out was 36, 6 times 6, times 1/3, times the height. Now, I drew my drawing a little bit small here, so bear with me. The key here is you want to draw in this auxiliary line. You see how there's a triangle being formed here? You've got 5, which is the slant height, like this, right? This is going to the center, so it's half of the side length. It's half of 6, which is 3, and we're looking for this height, which is right here, h. You can see this is a 3, 4, 5 right triangle, or you could do Pythagorean theorem. The height here is 4, so half of 36 is 12. I'm sorry, 1/3 of 36 is 12, times 4 is 48 units cubed since it's volume. Okay, letter C, I should say. We want to find surface area and volume of this pentagonal prism. Okay, the top and bottom are pentagons. They're separated by the height. Let's just make this height 10. Okay, so the surface area would be what? It's going to be 2 bases plus the perimeter of the base times the height. Let's do this part first. So the perimeter is 4 times 5, which is 20, times the height, which is 10, okay, which comes out to 200. But now the base, you see it's a regular polygon, it's a regular pentagon. So this is actually going to be 1/2 the apothem times the perimeter. 2 times 1/2, that cancels, so we just have to do the apothem, which they give us, which is 2.75, times the perimeter, which is 4 times 5, which is 20. Okay, so now if we do all this together, what do we get? We get 2 times, let's see, that's 27.5 doubled, which is 55. So this comes out to 255 for the surface area, units squared. And if we want the volume, we have to take the area of the base times the height. So it's easy to find the volume of a prism. Area of the base, 1/2 apothem times perimeter, times the height, which is 10. Let's see, the apothem we know is 2.75. The perimeter we know is 4 times 5, which is 20. 5 sides. So let's see, we get 200 times 1/2, which is 100, which would give you 275 units cubed for the volume. Okay, now for letter D, we've got a sphere, and the surface area for a sphere is what? 4 pi r squared. The volume is 4/3 pi r cubed. So sometimes students get these a little bit confused, but remember, cubed is 3-dimensional, squared is 2-dimensional, that's area, cubed is 3D, that's volume, right? So really there's only one dimension here, there's just the radius, which is 3, so put that in there. 3 squared is 9, times 4 is 36 pi, okay, units squared since it's an area. 3 cubed is 27, here let me write this out, 4/3 pi times 27. The 3 and the 27 you can reduce, So that also comes out to 36 pi, but now this is units cubed. They don't always work out to be the same like that. In this particular case they did, but the dimensions are different. This is units squared, this is units cubed for volume. Okay, let's go to the next question. Okay, home stretch, number 52. It says draw a net for a square pyramid. So we know what a square pyramid looks like. It has a base that's a square, right? It has triangles for sides. If you unfold this, here's your square base, and then you've got 4 triangles coming off the sides. So that's your net. You're laying it flat, you're unfolding it. Okay, number 53, it says how many planes of symmetry does a cone have? Okay, well we know what a cone looks like, right? And symmetry means it's the same. So if you take a plane and you cut through this, how many ways can you cut through it in such a way that each side, is a mirror image of the other side, right? Well, if you think about looking at a cone from above, from the sky, see, you could cut it like this right through the vertex. You could cut it like this, like this, like this, infinite number of ways. So in this case, there's an infinite number of planes of symmetry. With a regular hexagonal prism, though, what this means is that you have 2 bases which are hexagons, right? Something like this, okay? And so what you could do here is, again, if you look from above, you can say that there's how many planes of symmetry? Well, you can see it could go like, for example, like this, like this, like this, or through the corners, 4, 5, 6, and you might stop there and say 6, but you could also draw one right like this if you're cutting it in half. So there's going to be 7 planes of symmetry where it's going to be a mirror image on either side. Number 54 says, what is the probability that you pick a red marble, set it aside, then you pick another red marble from this hat? You mix them all up, you're blindfolded, you reach in. What's the probability you pick a red marble? You set it aside, you pick another red marble. Well, there's 3 red, 2 blue, so the probability of picking a red is 3 out of 5 for the first one. Now say you pick that red marble, what's the chance of picking another one? 2 chances of success out of 4 total. And you multiply those together. So remember, probability, it's the number of successes out of the total possible outcomes. But then it changes for the second draw because this is without replacement. Keywords to pay attention to: with replacement, if you put it back in, it would be 3 out of 5 again. Without replacement, you have to consider the new probability. So if we multiply these together, we get 6 over 20. 6 over 20. If we reduce that, we get 3/10. So that's your probability. Last question, number 55. In your school of 2,000 students, 300 run track, 150 play soccer, 75 do both. What is the probability that a student picked at random doesn't play either? So what we're going to do here is we're going to draw a Venn diagram. Okay, so here's all the people that run track. Here's all the people that play soccer. Here's the 75 people that do both. See, that's in the overlapping region. So if there's a total of, let's see, how many play track? 300. That means there's 225 that run track but don't play soccer, right? Of the 150 people that play soccer, 75 do both, 75 just play soccer. Now here's the thing, if you add up all these students, what are we getting? We're getting 375, right? But we said there was 2,000 total in the entire school. So what's 2,000 minus 375? It's 2,000 minus 375, that's 1,625, right? So that means there's 1,625 outside of these sets. And the probability that we pick somebody at random from the outside, that they don't play these sports, is going to be 1,625 chances of success out of the 2,000 total students. So that's your probability, and you can reduce that down. Let's see what that comes out to. 13/16 would be your probability, so equals 13/16. So I hope this video helps you boost your score on your geometry final exam, or if you're just reviewing geometry, I hope it helped you to review these important concepts. Subscribe to the channel. Check out more math videos on geometry if you're interested on my YouTube channel, Mario's Math Tutoring. Reach out to me if you have questions or comments, or you want to do some tutoring, or you want to have access to some of my courses. I look forward to helping you in the future videos, and I'll talk to you soon.